Hey guys, alright, so for this video we are going to do the last two examples in section 3.4. First, go get your calculator. Alright, so hit pause and go get it. It's easy to watch me do it, but when it comes to your test, you're going to have to press these buttons, so might as well follow along. So, hit pause, go grab your calculator, and come back. The Golden Gate Bridge, a suspension bridge, spans the entrance to San Francisco Bay. It is 746 foot tall towers are 4,200 feet apart. Okay, so its 746 foot tall towers are 4,200 feet apart. The bridge is suspended from two huge cables more than 3 feet in diameter. The 90-foot wide roadway is 220 feet above the water. The cables are parabolic in shape, that means it's a parabola, and touches the road surface at the center of the bridge. Find the height of the cable at a distance of 1,000 feet from the center. Okay? We all know San Francisco, and we all know the famous Golden Gate Bridge. So let me give you a real picture of when it was built. So this is the Golden Gate Bridge as it was being built in 1937. Isn't that crazy? Okay, it's really old. So it's talking about these two towers right here. Okay, and this rope is touching it right in the middle. Okay, so this is sort of like a 2D picture of that piece. So let's fill in some things, okay? Sentence number 1. The Golden Gate Bridge, a suspension bridge, spans the entrance to San Francisco Bay. So, first sentence is informative. Nothing there that we need to use. It's 746 foot tall towers. So, each tower, here's tower number 1, and here's tower number 2. It is 746 foot tall, and looks like it's from the water. And they are 42 feet apart. Okay, so this entire distance from the two towers are 4,200 feet apart. Okay, that means half of it would be 2,100 feet, and the other half would also be 2,100 feet. So let me just zoom in really quick. Alrighty then. So this piece right here, okay, we kind of look at the drawing and we got it. Because this is notes, I'm kind of already giving you the drawing in your own homework on the test. You might need to do the drawing on your own. The bridge is suspended from two huge cables more than 3 feet in diameter. So let's stop right there. So let's look at this drawing right here. See the two cables? One cable, two cables. Okay, and it's talking about how wide the cable is. So that piece of information is just extra information that I'm not going to need. The 90-foot wide roadway is 220 feet above the water. So this piece I might need. So here's the water right here, which let's give it blue, right? Here's water. Ooh, water, water, water. Okay. And it says, hey, a road is right here. And this is then from the water to the road is 220 feet. So we got that filled in. We are good. The cables are parabolic in shape, meaning that it's going to be a parabola, and touches the road surface at the center of the bridge. So here's the center of the bridge, and it's going to give me a 0, 0. So it's really talking about the origin. So here's the y-axis, here's the x-axis, okay? Find the height of the cable at a distance of 1,000 feet from the center. So I'm going to color this in purple. So if I'm asking this, how tall is this? Okay, that's what I'm really asking. How tall is that if I know I'm 1,000 feet from the center? And it doesn't matter. You can go right or you can go left. Okay, so let's find out. So let's write our answer first, and then we can do the work to find it. The height of the cable at a distance of 1,000 feet. Oops, let's move this way. The height of the cable at a distance of 1,000 feet from the center is, and then we can fill that in. Here we go. Let's zoom out. Let's do the work. Okay. We know that this is a parabolic shape, so we can write our equation in two formats. Y equals ax squared plus bx plus c, or we can write it as a vertex form. We've seen both recently. Y equals a times x minus h squared plus k. Both of these are known. Okay, so you can pick whichever one is easiest for you. This equation right here, it's easier, I should say, if vertex is known. Okay, so let's look at our drawing. Do we know the vertex? Sure, we do know the vertex. See, this is my parabolic shape. The vertex is 0, 0. So let's fill it in. Y equals a times x minus 0 squared plus 0. So that's really going to end up with y equals a times just simply x squared. So we need to find an equation of the parabola. Now we have y equals something x squared. Now we just have to find a. We know it opens up, so we know a has to be positive. Okay, so to find a, use one of the point that's on the parabola that's not already used. We've already used the vertex, so we can't use that again. So I can either use this or that over there. Okay, so use a point on the parabola. And the most important thing is that it cannot be used already. Okay, so I'm going to use whichever one you want. This one or that one? Okay, which one should we use? Which one should we use? Okay, let's go with this. Negative 2100, comma, 526. So now that that's the one we're going to use, let's plug it in. Every time I see a y, I'm going to put in 526. So 526 equals a. I'm trying to find a. Every time I see an x, I'm going to put in negative 2100. And then because this is x squared, we need to square that. Well, negative number square is going to give me positive anyway. So I'm going to divide both sides by, let's see, what's 2100 squared? Woo, huge number. Here you go. So divide both sides by 441. And then we have, how many zeros? 1, 2, 3, 4. So 1, 2, 3, 4. So 4,410,000. So divide both sides by that. 4,410,000. Okay. So A is going to come out to be this. 526 over 4410. And then 3 extra zeros. Okay. Moving on up so we can see. And on out. There. So we have a. Let's put it back. Okay. So my equation of a parabola is going to be y equals 526 divided by 4,410,000 x squared. That is just to find the equation. We haven't really answered any question yet, right? So now our question is, the height of the cable at a distance of 1,000 feet from the center is. So I'm looking for the height. So that means I'm really looking for y. But I do know x. X is 1,000 feet from the center. So now I'm just going to put in 1,000 for x. Let's go. Y equals 526 over 4,410,000 times x is 1,000 squared. Okay. Let's enter it all in your calculator. So 526 divided by 4,410,000 with 3 zeros. Hit enter. Some small numbers, but carry it over. So hit answer times, then 1,000 square. All right, look at that number. Let's see, about 119, and the unit of measurement was feet. Okay, so y comes out to be 119 feet. Okay, so now that we have all of this, see that right there? We can enter that in. The height of the cable at a distance of 1,000 feet from the center is 119 feet. And that, my dear, is the end of example 4. Pretty simple, pretty straightforward, right? Once you know how to find the equation of your parabola. And this one is easy if the vertex is known. Okay, if the vertex you don't know that, then you can use either one. Okay? All right, if you don't understand that, please hit pause and just listen to it again. We're now moving on to the last example of today. And this would definitely require you to use a calculator because this is a regression, data stuff. Okay? Okay, here we go. Zoom in, make sure I see all my stuff. Okay, can you see that? I want to make sure you're okay to see. Example 5. A farmer collected the data given on the table over here, which shows crop yields, which is Y. So let's highlight crop yields, which is the dependent. So crop yields is dependent on the fertilizer use. Okay. Part A. With a graphing utility, draw a scatter diagram of the data. Comment on the type of relation that may exist between two variables. All right, let's use your calculator. Enter in the data, clear it out my stuff, hit stat, go to calc, nope, go to edit. Okay, I have stuff right now in my L1, go up, hit clear, go back down, it's empty. Go over to L2, go up, hit clear, go back down, it's empty. Awesome, right? Okay, let's go to L1. L1 is always going to be your independent. And based on this, independent is the fertilizer used. So this is our fertilizers used. This plot right here, it doesn't mean anything because it's only, look at the way that it's defined. You're only using fertilizer used and then the crop yields Y. So fertilizer X. Here we go. Enter it in. 0, 0, 5, 5, 10, 10, 15, 15, 20, 20, 25, 25, 30, 30, 35, 35, 40, 40. So it looks like the last number is 40, and that gives me like 18 plot right here, right? So that's 18 plot, which kind of lining up with what that has. Over here, list 2 is always going to be the dependent. In this case, is the number of crop that's going to yield. So 4 bushels, 6 bushels, 10, 7, 12, 10, 15, 17, 18, 21, 20, 21, 21, 22, 21, 20, 19, and 19. All right, now let's double check. Are these two lists lining up? Okay, they both should have 18 plot on each. Okay, so it says, with the graphing utility, draw a scatter diagram of the data. Comment on the type of relation that may exist between the two variables. So hit stats. Go over to calc, and I want you to do a linear regression. Okay. You know what? Let's go to y equals. Actually, let's clear out the stuff. Let's go to plot, highlight your plot. Okay, and then zoom stats, which is number 9. Okay, so check that out. Is that a linear regression or is that a parabolic regression? Quadratic. from the way that this is, okay, we need to comment on the type of relation that may exist between two variables. The two variables have a linear relationship or a quadratic relationship. Hopefully, I think you are mumbling a quadratic relationship, right? Relation. I can't spell shit. Okay. So the variables have a quadratic relationship. Use a graphing utility to find the quadratic function of best fit of these data. Ooh, look at that. Okay. So to find this, you would do the same way. You would hit stats, you go to calc, instead of go to linear regression, you go to quadratic regression, which is right here. Okay. Hit enter. If you have an older calculator, hit enter one more time, and then that will do it for you. If you have this kind of newer one, actually go down to calculate and hit enter. Okay. Notice how my r-square value is not here. I'm going to try to find it. To find r-square, second catalog. So second catalog. And just bring up a bunch of stuff here. I want you to go find the word diagnostic. Okay. And I want you to turn it on. So make sure the arrow is pointing on. It is on your screen now, but it's not on yet until you hit enter one more time. Okay, until it says done, then now is on. So go back to stats, calculate your quadratic regression again. This time, it should give you an r-square value. Oh, damn it. Okay. Notice my r-square value is 0.95 or 0.94939. This is like 95% that is that the variation or this model fits this data nicely. Now, what if I do stats, calc, linear regression, okay, which is this line? I want to see what the r-square value is. See, r-square value, not r square. R-square value is now 0.76, so 76% that is that it fits nicely. So what we want is, since this is a lower percentage, we want to have the quadratic regression. Okay, that means the variation is not very much. The higher the r-square, the better it fits. Okay, so because this r-square is almost 95%, this is a better model. So it says here, use a graphing utility to find the quadratic function of best fit. So let's see. Our function of best fit is y equals ax squared. So your a value is negative. Okay, right over here. Let's round to 4 decimal places. So negative 0.0171x squared plus let's see what that is, 1.4 decimal places, 1.0765x plus your c value is 3.8939. So that is my quadratic of best fit. All right. Part C, use the function found in Part B to determine the optimal amount of fertilizer to apply. All right, so now that we have that equation, go to y equals, put in that equation. Look at that, okay? Negative 0.0171x squared plus 0.0765x plus 3.8939. Okay, let's go to zoom and let's go to stats, zoom stats, okay, which let's move up really quickly, zoom stats and hit enter. It draws it for you. Okay, so now part C says find the best, okay, use a function from part B to determine the optimal amount of fertilizer to apply. The word optimal is what's the best amount of fertilizer to use. The best amount of fertilizer to use is, okay, let's check it out. That means I want my max, second trace, max, Okay, go ahead and do that for me. Left bound, right bound, and I do expect you to write the answer, so go ahead and fill that in. Okay. If you can't or you don't want to try this on your own, you're not going to be very successful. And then you can be mad at me, but then it's really on your own doing because you're not doing what I'm asking you to do. Okay, so go ahead and find the answer. So the question is, when you do your maximum, you have two answers, the x answer and the y answer. Okay, which one would you look at if I'm answering the question of fertilizer? You should look at your x, right? And notice how fertilizers measure all in whole numbers here. So just give it to me in whole numbers, okay? And so we're going to have to also use the units of measurement. So notice how each fertilizer is measured in pounds. So we write pounds, LBS, for every 100 square feet. Okay, so for pounds, 100 square feet. And that is the unit of measurement for fertilizer. So if you have whatever number here, that's a blank number of pounds for every 100 square foot. All right, let's move on to D. Hopefully you found that amount. Part D, use the function found in Part B to predict crop yield when the optimal amount of fertilizer is applied. In this particular step, you don't have to do any more work. Okay, it's the same screen of Part C. So the maximum bushels yield, okay, the maximum bushels yield when the optimal, let me zoom back out, when the optimal amount of fertilizer is applied is, okay, the maximum bushels yield when the optimum amount of fertilizer is applied is, so go ahead and fill in this right here. Let me zoom out some more. Okay. And remember, you don't have to do any more work from the previous step. You just have to write the correct number of bushels here. And again, looks like it's rounding to whole numbers, so just round this to whole numbers for me. Okay. And the units of measurements is, okay, so the maximum bushels yield when the optimal amount of fertilizer is applied is length. Because I already have the unit of measurement right here, you don't have to put it back here. All right. Okay, so now that we have those answered and doing one step. E, draw the quadratic function of best fit on the scatter diagram. For this one, I'm not going to ask you to do it by hand, but I'm going to ask you to give me the window of your calculator. So what is x min? What is x max? What is y min? And what is y max? If you are following this notes with your calculator, you should have all of these blank spaces, okay? If you are not, then you just need to rewind it and start from the beginning with your calculator. With that said, I will see you in class with all the blank spaces filled in. Have a wonderful day. Bye-bye.